Hello friends, in this video we will discuss some of the questions that were asked in JEE main exam in February this year on 24th Feb 2021 in the morning shift. This is the physics portion of JEE main exam. I have copied some questions on the slide itself for your reference. Questions were fairly simple. So if we consider this first question, it says that two identical capacitors, first they are connected in series and then connected in parallel. We have to determine ratio of effective capacitance in the two cases. Now, when they are connected in series, effective capacitance is given by the formula 1 by C1 plus 1 by C2. Since capacitors are identical, so C equivalent becomes C by 2. And according to the given question, C1 should be equal to C by 2, where C represents capacitance of each of the identical capacitor which have been connected in series. Now, when they are connected in parallel, equivalent capacitance is C1 plus C2. It becomes 2C. Therefore, effective capacitance in parallel will be 2C. We have to determine C1 by C2, which comes out to be 1 by 4, and hence the correct option is 4th. Now we come to the second question. So we have been given an arrangement of charges on the vertices of a cube. Now, except for the charge at origin, all other charges are positive. So we can think of it as if all the charges, including the charge at the origin, were plus Q, then by symmetry, electric field at center of the cube must have been 0. So if all were positive charges, that means if minus Q was replaced with plus Q, then field at center of the cube must have been 0 by symmetry. Now, field at the center of cube due to this negative charge is expected to be towards this charge itself, and since if all the charges were positive, field would have been 0 at the center, and if we consider a positive charge placed at the origin, field due to a positive charge at origin must have been opposite to the field due to the negative charge. Okay. That means this will be the field at centroid due to a plus q charge placed at origin. Now, if all the charges assumed positive were giving a 0 net electric field, therefore, field due to all the remaining charges except the positive charge at origin must have been equal and opposite to field due to positive charge at origin. This can be treated as resultant of field due to all the remaining positive charges. Now, in actual distribution, instead of this positive charge, we have a minus q charge. So, overall field due to the given distribution should be equal to sum of these two fields. Now, ER will be equal and opposite to field due to a positive charge at the origin. E negative will also be equal and opposite to field due to a positive charge at origin. So we can very well imagine that resultant field due to given distribution of charges should be equal to negative of 2 times field due to a positive charge plus q placed at origin. So E positive basically represents field at center of Q due to plus Q charge placed at origin. So now we just need to identify field due to this positive charge. Now this can be written as constant of proportionality in Coulomb's law into magnitude of this charge divided by distance from origin to centroid, which should be equal to root 3 times side of the cube divided by 2 its whole square. Basically, length of body diagonal of the cube is root 3a So distance between vertex and the center of the cube becomes root 3a by 2, and this gives us the magnitude of field due to a plus q charge placed at the origin. Multiply this by a unit vector directed from O to G to give direction of E positive. So that can be written as I plus J plus K, converting it into unit vector divided by magnitude of this vector. So rearranging, I will get we also put the value of K. So 1 upon 4 pi epsilon naught. This becomes 3a square. 4 goes in numerator, root 3 I plus j plus k. So we get q upon I 3 root 3 epsilon naught a square I cap plus j cap plus k cap, and putting the value of E positive in this expression, we get correct answer as first. The third question is related to parameters of a transistor. We are given that an increase in emitter current of 4 milliampere leads to a corresponding increase in collector current of 3.5 milliampere. Delta IC is 3.5 milliampere. Hence, value of alpha becomes delta IC upon delta IE. So 3.5 upon 4. Seven by 8. Now beta, which represents change in collector current corresponding to some change in base current. This is related to alpha by this relationship. Therefore, we get third option as correct. In the fourth question, this is based upon Young's double slit experiment. The ratio of width of the slits is given to us, and it is also given that amplitude is proportional to width of the slits. Amplitude of interfering waves from two sources is directly proportional to width of the slits. So this becomes A1 by A2. We have to determine ratio of maxima and minima of intensity in interference pattern obtained on the screen. Now I max upon I minimum is equal to A2 plus A1 upon A2 minus A1 whole square. Now if I take A1 as x units, A2 becomes 3x. So we get four is the answer. Hence, third option is correct. Hope you find it useful. Thanks for watching.